Hello class, this is a continuation on the signs of functions to solve inequalities. So by using a table of signs, we can more easily solve harder inequalities. Just to demonstrate how we did this before and the problems that we encountered, let's solve this as we normally would have. Let's factorize this. You should get x plus 2, x plus 3 is less than 0. Solving this, we get x plus 2 is less than 0. X is less than negative 2. X plus 3 is less than 0. X is less than negative 3. Now, if you really interpret what this means, this doesn't quite make sense. It's saying it's less than 2 and it's less than negative 3. So, normally we would have picked a value, let's say x is equal to negative 4, and tested that, and to test whether this is true, and then we would pick x is equal to, let's say, 1, so this is greater than negative 2, and we'll test that and see which one is wrong and flip one of the signs to make sure. But we'll see now, by using a table of signs, we can avoid those problems. So let's actually use the solutions that we have. But rather than have it less than, let's just keep it as equal. Now let's use a table of signs to solve this. Whoops, didn't solve this one. Let's just skip a few points here. Let me just redo this. X is equal to negative 2, x is equal to negative 3. Making a very rough table of signs. Let's pick negative 3, negative 4, negative 2.5, negative 2, and 0. We know that negative 3 and negative 2 are going to be 0. Now let's just double checking whether it's positive or negative. 0 is very easy. That's the that's the y-intercept. The y-intercept here is going to be 6, which is positive. Substituting values into the factorized form makes it a lot easier. So I'll demonstrate to you here. Negative 4 here and here. So in my mind, this is what's happening. Negative 4 plus 2, negative 4 plus 3. Negative 4 plus 2 is negative. Negative 4 plus 3 is also negative. And two negatives multiplying gives us a positive. It's going to be positive there. You can check using a calculator to ensure that that is correct, but I can guarantee you that's what's happening here. Let's do it again here. Negative 2.5 plus 2, that's negative half. Negative 2.5 plus 3, that is going to be positive half. Positive 1.5, I think. Yes, positive 1.5. Negative times positive is negative. So this is going to be negative there. So without having even to use a calculator, you can if you want to, you can figure out the signs of a function like so. Well, now that we have the table of signs, we can solve this inequality. It's asking now, where in this inequality, or in this case a parabola, where is the parabola less than 0? Well, we can clearly see that between negative 3 and negative 2, the graph is negative. So the solution to this is x is less than negative 2, but in this case it's greater than negative 3. That there is our solution, and I hope you still remember bracket notation. So open bracket, negative 3, negative 2, and there we have it. So you can go ahead, give these a go yourselves, and I'm going to solve them in 3, 2, 1. Here we go. So factorizing these again, we should get, let's double check this, x plus 3 x negative 6. Yep, that's working. Just let this equal to 0, and we get the solutions. X equals negative 3, x equals positive 6. Making a very rough table of signs. Negative 3. Pick any number in between. Let's just pick the y-intercept. Makes it a lot easier. Positive 6 and 7. There we go. Let's pick a number, negative 4. We know that negative 3 and 6 are 0, so let's write those in. And now let's test these values into the factorized version. Oh, actually, we already know that this is going to be the y-intercept. We can see that the function has a y-intercept of negative 18, so we know that's going to be negative. Substituting negative 3 here. So we already know that one, sorry, negative 4. So let's do this much faster. Negative 4 here and here. This will give us negative and negative. Two negatives multiplying gives us a positive. Same thing for here, negative 3. What am I doing? 7 here and here. This will give us 10. This will give us 1. Multiplying the two, we get a positive. And there is our solutions. Now it's asking, where is the parabola greater than 0? Well, we can see from greater than or equal to 0. We can see that from 6 and to the right, it's 0 and positive. So our solution, our first set of solutions here is x is greater than or equal to positive 6. And you can also see from negative 4 and to the left, so anything negative of negative 4 is also positive. So it's going to be x is less than or equal to negative 4. Solving this in bracket notation, I hope you remember this, from negative 4 and on to negative infinity. So everything to the left of negative 4, union with 6 to positive infinity. There's our solution. Let's do this one more time here. I can show you a few tricks to make this a little bit easier for you to factorize. Let's just multiply everything by negative 1. So we get positive x squared, positive 2x, negative 15. We just flip the sign. And we solve for this. We should get 5 and negative 3, x plus 5, x negative 3, x equals negative 5, x equals positive 3. And on to our table of signs. Negative 6, negative 5, 0, 3, and 2. 4. You can possibly see I'm getting faster and faster and more messy. We know that these are going to be 0, y-intercept into our original function. Well, it's positive. That's going to be positive. Placing negative 6 into here, we get negative 6 plus 5 is negative. Negative 6 minus 3 is negative. Two negatives multiplying. Oh wait, no, sorry. Negative 6. Negative 6 plus 5 is negative. Oh, sorry. I'm substituting into the wrong one. I need to substitute into the original function. So here we go. Well, there are a few details you can actually use, but I'm actually going to show you that now just to save some time. This is a parabola that's concave down, and we've already figured out where it's positive. So it's concave down like this, and here are its x-intercepts, negative 5 and 3. The rest have to be negative. You can double check that by using the calculator, but there's a little trick you can use. And now it's asking, where is this function greater than 0? Well, we can see that between negative 5 and 3, it's positive, So our solution is going to be, is equal to, greater than or equal to 0. So between -5, so x is less than or equal to 3, but greater than or equal to -5, and in bracket notation, there we have it. And just to solve this and finalize this, as I was mentioning that these are actually parabola, let's not forget to consider the graphical meaning of these inequalities. So these are the exact same 3 functions that we just worked with. The first one asked, where is the function less than 0? Well, between 2 and 3. In this one, where is the function greater than or equal to 0? Well, between less than 3, so here, anything to the left of -3, and anything greater than or to the right of 5. It's positive. And lastly here as well, we can see from between, well, it's asking where is this parabola greater than 0? Well, from -5 to 3, it's positive and above the x-axis. So I hope that gave you an insight into using the table of signs to solve harder inequalities, and give you more insight into interpreting graphs and what they might look like. Hope to see you in the next video. Best of luck.